Yeah, good morning, guys. Good afternoon. Welcome to the session. So, I see very less people here. People are still joining. So, let's wait for another 5 to 10 minutes, then we'll start. Okay. Let everyone join the session, then we'll start. And guys, people are still joining, so let's wait. Okay. So let's start in another 2 to 3 minutes. Okay. Let everyone join the session, then we'll start. Yeah, good afternoon, everyone.
Okay, good afternoon, everyone. So I hope everyone is here, and I also see that the strength is very low today. Okay, fine. So what are we discussing yesterday? We had discussed about this RAG architecture, right? RAG, Retrieval Augmented Generation. Understood that workflow and the architecture? Anyone having any doubts? If anyone is having any doubts related to the RAG architecture, how the retrieval is happening, and how those tokens or the vectors are being augmented, and then the output is being generated. If anyone is having any doubts in that workflow, do let me know through Q&A. Okay, just give me a minute. Let me just share my screen. Just a moment. Okay, I'm sharing my screen. Just a moment. Do let me know once if my screen is visible. Okay. Hope my screen is visible now. So, how many of you are aware of this concept? Aware of this architecture? Fine tuning. Let me know in the Q&A, guys. Fine tuning architecture. See, I told you right in LLMs, and nowadays, if we see, the first one is the RAG architecture, which is very popular nowadays because if we want to deal with any document where we don't want to expose our data, or else we don't want LLM to train on our data, then in those scenarios, we'll be going for RAG, okay? And fine tuning is nothing but in fine tuning, you will be training the LLM or else the pre-trained model on your own data, okay? On your own data, you will be training that pre-trained LLM. So that is what the fine tuning is. But in fine tuning also, we are having different concepts. We'll explore that, okay? Okay, so what's the agenda? So we'll get to know what are all the components which are present in the fine tuning, and also popular fine tuning techniques we'll get to know, okay? Fine. So first initially we'll see what exactly is fine tuning. Key components. Introduction to fine tuning. Fine tuning. Fine tuning will work with the LLMs, correct? I told you. And how we will be working? Whatever the data which we are having, okay? Whatever the data which we are having, we will be telling the model, okay, or else we'll train the model on that data also, okay? On that data also, we'll train the model. So that is how we'll be making sure that the model is learning on our data also, okay? So that is what exactly the fine tuning is. Fine tuning, we are having some components also, and some of the techniques we are having for fine tuning. We'll see what exactly they are, okay? So understood, right? Fine tuning is, it is a technique which is used to improve the pre-trained model, correct? It will improve the performance of a pre-trained model based on a specific task or a data set, okay? And key components of fine-tuning or pre-trained models. What are the key components and why fine-tuning is essential? See, fine-tuning is very essential for optimizing the model performance, and it will also leverage the existing knowledge from pre-training. And that process is efficiently, it adapts the models to new datasets or tasks. See, that is just the definition of fine-tuning, okay? So in simple words, we'll have an LLM, we'll have our own data, and we'll make sure that the LLM is also being trained on our data. That is what the fine tuning is. Okay. So training data set. To fine tune the things, or else to fine tune an LLM with our data, what are the required essentials? We need to have a data set. Correct. We need to have the data. And how the data should be: high quality data, data diversity, and also larger data sets which are leading to better and generalization. Okay. See, the high quality data means what? We need whatever the data which we are having, we need to make sure that that data can be used for processing, or else can be used for this fine tuning purpose. Okay. So whatever the data which we are having, we need to make sure it's completely clean and pre-processed. Okay. And then comes this data diversity. What is this data diversity? Diverse data, it will cover the edge cases, and it will also aim for 95% of labeled accuracy. Okay. It will also aim for the accuracy. So data diversity is nothing but it should cover all the edge cases. Whatever the new information that you are giving, it should cover the edge cases. Okay. Then larger data sets. Larger data set will lead to better generalization. Like example score, which has a 100K examples. Okay. So we need to make sure that whatever the data sets which we are having, we are not training on a smaller data sets, small size data sets. We need to make sure that we are having a large amount of data set, because we are doing a fine tuning process. Fine tuning process is completely expensive, computationally very expensive, because we are making sure that the model is training on our data also. It will be completely trained. Okay, it will be completely trained. New parameters will be found, and whatever the existing parameters are there, to that, in addition to that, the newly found parameters will be added. Okay. Okay, model parameters. What is this model parameters? Pre-trained weights, selective fine tuning. Anyone heard of these parameters? Model parameters, weights, and bias. We'll discuss about this model parameter. Okay. So what exactly are model parameters? They are, see, we'll be having the variables, right? So model parameters are nothing but the variables that are adjusted during the training process. Okay. During the training process, whatever the variables that you are adjusted, that you are adjusting, that we'll be calling it as model parameters. Okay. And we also have internal variables which will define the model's behavior and prediction also. And in this in the model parameters, we are having types. So types will be weights and bias. Okay. Weights and bias. So weights and bias. Weights is nothing but it will determine the relationship between the input and output. Correct. We all know that why exactly weights are required. Correct. So similarly, we are having this concept called bias. So which is added like a constant to the weighted inputs. Correct. Why it is added like a constant? To shift as per the activation function. Okay. Selective fine tuning, pre-trained weights. Pre-trained weights is nothing but the already trained weights. Okay. Whatever the model, let's say I'm having a small language model. Okay. I'm having a small language model where its size could be 1 billion or else 1.5 million. Okay. So in addition to that 1.5 million, whatever the extra data set that we're trying to do the fine tuning, for that particular data set also, we'll get some parameters. So in the combination of that LLM and this new data, we'll get a completely new model. Okay. We'll get a completely new model. So all those weights will be added. Okay. All those weights will be added. So pre-trained weights is nothing but the whatever the weights which are existing. Okay. Learning rate is another important factor. So in the learning rate, why learning rate is important? Why smaller rates or else large learning rates should not be applied, and how this learning rate should be applied, we'll see. Okay. Remember the gradient diagram? Remember the gradient diagram? Anyone? See, just drop your response like yes or no. Okay. Everyone understanding what exactly I'm saying? Okay. Learning rate. So fine. Thank you. So learning rate, we are having critical hyperparameters, smaller rates, learning rate schedules, and improved accuracy. So if you see over here, critical hyperparameter, what it is saying, the learning rate will control the parameter update, and it is a crucial hyperparameter because why learning rates are important. Based on the learning rates only, the model will tend to learn the data. What is the smaller rates? Using the smaller learning rates for pre-trained models such as 1e to power of 5, I mean minus 5, or else 1e to power of minus 6. These are all the smaller learning rates. Okay. 1e to power of minus 5 is nothing but it will be 0.00001. Okay. I mean the learning rate will be that slow or else at that speed. Okay. So that is why 1e to power of minus 5 or minus 6. Okay. So learning rate schedules. No. So what it is saying, implemented learning rate schedules decades over time, adaptive rates like Adam also helps. So while working with this learning rate, okay, while working with this learning rate, Adam will also be helpful. What is Adam? What is Adam? And Adam is a combination of RMS prop and also momentum, right? RMS prop, momentum, optimization algorithms. Okay. And this learning rate will also help us to improve the accuracy. Okay. You can schedule the learning rates. The smaller learning rates will be like 1 e to power of minus 5. Okay. And they will also help us in improving the accuracy. Okay. Optimization algorithm. So what is this optimization algorithm? Adam, SGD. Okay. These are all the optimization algorithms. Okay. So parameter updates, Adam, SGD, and performance gains. So what is parameter updates? Algorithm update models parameter. Okay. The algorithm will be updating the model parameters, which will ensure there is a efficient training happening. Okay. The algorithm will update the models parameter, and in return it will ensure that the training is having or else happening efficiently. Okay. So then comes the Adam. So Adam will offer the adaptive learning rates per parameter, and it is widely used. Then we have SGD. What is SGD? SGD is a classic with momentum. Okay, we'll have the momentum also over here. Gradient descent. Okay, SGD is stochastic gradient descent. Okay, it's a gradient descent again, type of a gradient descent. It is very simple and also very effective. Okay, we are also having this performance gains. What is that performance gains? RMW or else Adam is outperformed by RNW by 3% on ImageNet. choice depends on the model and the data. Okay, so it depends. See, every time we can't say like I will use only ChatGPT, or else I will use only Gemini, or else I will use any other LLM in order to resolve my issue. I need to try out different LLM responses, right? So in a similar way, according to the model, or else depending upon our data, depending upon the domain of the data, we need to choose the model. Okay. Okay, loss function. So what are the loss functions here? Cross entropy, mean square error, focal loss. Okay. So what is cross entropy? It will quantify the prediction error. Okay. It will identify the predicted error. And also it will do the classification task. Okay. It is for classification task. Mean square error is for regression task. Focal loss is for object detection. Okay. And this focal loss, mean square error, and cross entropy are the loss functions for classification and regression and object detection type. Okay. And what exactly this is saying? It will measure between the predictions and the ground truth. Okay. Just go through this training loop once. Go through the training loop. So everyone has gone through the training loop. So what exactly the process is, how the process is happening? Iterate the data set, prevent the overfitting, early stopping if needed, and epochs. Correct. So how is the training loop here? We need to initially iterate over the data set. So how exactly we can do that? We can initiate a training loop and iterate over the complete data set. Okay. And which will happen multiple times per epoch. Okay. For epoch, it will happen multiple times. And we are also having this prevent overfitting. What is that? Monitor validation loss closely, which will prevent the models overfitting. Okay. So whatever the loss it is generating, we need to monitor that particular loss and we need to keep it low, which will help the model to prevent the overfitting. Okay. And then comes the early stopping. Important. Early stopping is one of the cross validation technique. Okay. Early stopping is one of the cross validation technique. Important. So halt the training when validation loss plateaus. This optimizes the efficiency. So we can stop the training directly when the loss is completely increasing. Okay. When the loss is completely increasing, we can completely stop that particular training stop. Okay. And then comes the epochs. So number of epochs varies because it will depend on the data set to data set or the dataset size, depend on the dataset size and also complexity. So usually few epochs are sufficient to do the process. Okay, few epochs are sufficient to do complete the process. Okay, these are this one batch size is an important factor again. What is batch size? Batch size will control the samples. Okay, batch size will control the how many samples should consider for one single iteration. Batch size will help us to define how many samples to consider in one single iteration. Okay, 32 will be the common batch size. Okay, 32 is common batch size, and then comes this faster or the larger batches. What does it exactly mean? Larger batch size leads to faster training. Correct. And also, if you see the second line, what it is saying, this is true up to a certain point because not all the time. Okay. Sometimes larger batch size will lead to low computation. Okay. I mean, like, let's say I'm having a computational resources very low. Okay. So in that case, what exactly happens is the large batch size can lead to a faster training, or else it can lead to a slowest training process also. Okay. So the minimal by default or else commonly used batch size is 32 mostly. So how exactly it is better? Smaller batches, smaller batch size. It will improve the generation process also, and it will prevent the memorization process also. Okay, just go through the slide once. So I hope you have gone through this slide. So regularization and avoiding the overfitting. So what is overfitting, guys? What is overfitting? Okay, dropout. Dropout is nothing but randomly deactivates the neuron during the training, which will prevent the co-adaptation. Okay. And then comes the weight decay. What is weight decay? Weight decay is nothing but it will penalize the large weights. Okay, it will penalize the large weights and simplifies the model. See, all these things you have already seen. Okay, but you just need to recall the concept. That's it. And even we are having this data augmentation. What is this data augmentation? What it is doing? Expanding the data set. It will create a diverse example. Okay. This is it, guys. Popular techniques we are having. Popular techniques we need to understand about this. Prompt tuning is nothing but updating the prompt and getting the desired response. That is what the prompt tuning is. Okay. We have this prefix tuning also and PEF, LoRa, and full fine tuning. Full fine tuning, what it does, it will just make sure that whatever the data set that we're having, it is being completely trained along with the data set. Okay. The model will be completely training with the data set. So full fine tuning, you all know LoRa and PEFT. LoRa and PEFT are two important techniques. Okay. LoRa and PEFT are the two important techniques. What is LoRa? LoRa is low rank adaptation, and it will reduce the training parameters also. What is PEFT? PEFT is nothing but it's an efficient fine tuning method. Okay. It's a efficient or parameter fine tuning technique. PEFT is. LoRa is low rank adaptation. Okay. These are some of the techniques. Okay, fine. These are the things you need to know. Okay. These are just the things which you need to be aware of. Okay? That is the reason I'm not going into. So initially we have discussed about this training data, model parameters, learning rate, optimization algorithm, loss function, training loop and epochs, batch size, regularization and avoiding overfitting. Okay. And then at last will come the techniques. Okay, techniques. Okay. So this is it for the fine tuning. Okay, this is it for fine tuning. I know fine tuning PPT, it will be completely similar to other PPTs also. But just let me know if you understood or not. Okay. I'll be waiting for the response in the Q&A.